Okay, so NASA spearheaded UTM, and now they're working on advanced air mobility research activities to help integrate these new aircraft into the NAS. So, and you know, I know NASA started in 2010 timeframe with UAS integration in the NAS, and then I think 2013 was UTM, and et cetera, et cetera. But now we have advanced air mobility, and over the last 2-3 years, it's now started to get a fair amount of traction, and it's now driving the industry. So it's my great pleasure to introduce Davis Hackenberg, Advanced Air Mobility Mission Integration Manager for NASA's Aeronautic Research Mission Directorate. His bio is on the summit. I look forward to hearing about AOM, the national campaign, and how NASA can stimulate the industry. So please have your questions ready. Use the Zoom chat and send them to me. And Davis, if you're ready, it's yours.
Yeah, quick sound check. Can you hear me okay, Wasim?
I hear you perfectly. Thank you, Davis.
Good. So Wasim, you know, to get started here, I'm a dad, so I'm a sucker for a bad dad joke or a good dad joke or whatever. I promise I laughed out loud. The virtual environment doesn't get you the laughs you deserve, but I'll use that joke at some point here in the future. I'm positive. And then
you may have liked yesterday's.
And Jeff, you know, these type of events in general, thanking AUVSI with this statement. It's a big time commitment for me overall to come to events like this and do these types of things, but I really value and cherish them. I mean, I get some of the hardest questions I get from external community stakeholders in the ecosystem and everything at events like this. And I can't say enough about how much this type of interchange that I have with people really influences me, teaches me things, and helps us at NASA grow our portfolio. So yeah, have your questions ready. Come up with the hardest ones you can. I'll do a good job at dodging them if I don't know the answer, but I promise, you know, I'll learn from them and I'll figure things out, and we'll at NASA, we'll take that information and use it. Yeah, so if we can just go to the next slide and I'll get started. I know you heard from Nathan yesterday. Agility Prime is one of the you know, top government activities out there that I've ever seen. You know, I think we have some great stuff going as well. The FAA is doing awesome things, but all this government activity and the industry activity, you know, from my perspective, is to create U.S. leadership in aviation, to keep U.S. leadership in aviation. Everybody's looked at the market studies at some level. You know, everybody hears the numbers between 300 billion to 1.5 trillion in economic impact by, pick a year, 2040. And it's clearly something that the U.S. has to stay in a leadership position on. If you look down the middle of this chart that just shows a few of the domestic companies that are doing really good things, you have 3 companies that are flying primarily urban air mobility aircraft. eVTOLs are those 3. Some of the pictures on here aren't eVTOL, like Alakai, that's hydrogen powered, but you can see by just the little labels that are shown as flown as to how fast this industry is progressing. And I'm lucky enough to see some of these things firsthand and just come here to tell you how real this industry is. I think probably, you know, most of you being members of AUVSI and such realize this, but as government agencies, it's our goal and, you know, the nation's need for us to help accelerate this stuff. So everything that I talk to you about is intended to leverage the great work that industry is doing and have NASA be a catalyst to accelerate this industry even more, to move us through the regulatory framework, to develop, you know, new policy that's going to help the U.S. dominate this industry long term. Next slide, please. It was about 2 years ago that we went public with our UAM Maturity Level, UML concept. At the time, we were really focused on urban air mobility. We still are pretty laser focused on urban air mobility, I would say, but we've advanced our messaging a little bit. We've learned a lot about the aircraft, different industry use cases and such, and we've kind of pivoted over to an advanced air mobility concept. If you look at the blue bar down at the bottom there, we talk about transformational local and intra-regional missions. So local is where that urban air mobility concept fits. Loosely, no real number associated with it. We say less than 75 miles. Some of the early electric stuff said less than 50 miles, types of things. But really, it's talking about from an urban center or across an urban area, that's about a distance you could get to. And if you can move people that within that local distance, 75-ish miles, you can really get a lot of economic impact, a lot of utility out of these eVTOL type configurations. That local also translates though to anywhere. It could be entirely rural for logistics missions, so on and so forth. It can go from rural to suburban, rural to urban, especially as you move into the intra-regional. If you look at the performance of many of these aircraft now, you're seeing numbers advertised at 150, 200 miles for an eVTOL aircraft that they can move people or goods. So those are the types of things that moved us towards our pivot. One of the things I like about this chart, it shows you all the different, variety of different use cases, I guess, that reflect back on what I was just saying. And it also kind of represents a lot of the different vectors, or what we like to say, that the industry is taking. So all of them have a goal to become scalable, sell thousands of aircraft. But the way they're going to get there is different. Some of the companies are going to go through piloted operations, try to use the current infrastructure policy stuff we have as of today to fly their vehicles. Others are going straight towards a more automated type of mission, which would be in many cases unmanned. You could look at two companies like Wisk and Joby and see the difference in what they're trying to do, but actually see the reality in what both are trying to do, and the benefit even to the different approaches that they're taking. I see companies trying to understand what other industry companies are doing so that they know how they're going to be able to leverage each other long term. And I see synergy across some of these companies as well, where they're learning to work together and almost delegating some of the automation to another company so that they can pioneer it first, while this earlier use case company is pioneering more of the infrastructure pieces and early adoption there. So I think it's a really good story. I think it's really good to keep in mind, and it also shows the complexity of what we're dealing with in some ways. You integrate drones on top of urban air mobility, on top of intra-regional advanced air mobility concepts, and the picture becomes complicated real fast. So it shows all of us how daunting it is, but at the same time, I want to add that reality back on that already exists out there in the industry. Next slide, please. So, a lot of times I take an industry focus. I'm one of our strategy people at NASA. I work with our associate administrator to make sure we're aligned with where the industry is going, and our research portfolio is going to be of maximum benefit to the bulk of the industry that's growing out here. But I also spend more than half of my time obviously focused on our internal work, what we're doing internal, how we integrate, and how we align with industry from a technology specific perspective. This chart isn't intended to represent all of the barriers out there. Obviously, this is intended to represent the specific things that NASA wants to be a leader on and tackle over the next 10 years or so as we try to progress out to UML4 in a 2030 timeframe. We organize things internally by pillars. You probably think of things similarly yourself. Down in the bottom left, pillar 1 is vehicle design type things, how you build the vehicle, the noise signature that it has, and then how it's going to work in environmental crash, other types of failure conditions. Pillar 2 over there on the right really is about the automation and autonomy. So pilots, how we're going to make things easier on them, how we're going to certify them more efficiently, and then how the autonomy is eventually going to take over and be a key capability that really makes this industry scalable. Our 2 airspace barrier, or pillars 3 and 4 up there, have a lot to do with safety overall, and the UTM type of work we've done and pioneered really over the last 6-7 years, as you referred to, Wasim. We refer to XTM architectures over there. It's not all unmanned anymore, right? But there are new architectures needed that are UTM inspired. Lots of procedures that go with these new things. How we interface with air traffic control will be different as this industry scales and progresses. ComNav, surveillance, information stuff, all different paradigms that we're moving into. So our airspace work is clearly one of our most important areas, and one of the areas we feel like we have a real strong leadership position. And then there's so much here about the localities and the communities and everything we're going to do and gaining acceptance that this is something we're pre-planning into our portfolio up front. We'll talk later about some of the partnership strategy stuff we have, but this community integration area is huge to us. Down at the bottom in the middle there, you see two of our cross-cutting areas that we're specifically designing up front to bring everything together. We're implementing model-based systems engineering practices across our mission to develop something that we've done really well, been really successful at, requirements that will represent this entire ecosystem. We'll spend a lot of time and effort aligning with standards bodies, aligning with regulatory, so we feel like this MBSE structure is an important thing. And then our national campaign activity, I'll talk about a little bit more, but same type of feel. It's intended to bring everybody together, our technologies, industry's technologies, all the best practices, ways to validate integration into the airspace, things like that. So national campaign is one of our centerpieces, and really those two cross-cutting things are something everybody, takes a lot of everybody's time across our mission internal, and we use as an external focal piece for the entire industry. Next slide, please. This is an overview of our national campaign. So one of the most fundamental things that we built into national campaign is leveraging it to ensure that we were gonna, as an outward-facing piece of our portfolio, we were gonna use it to demonstrate, show safety to everybody, not just the people building the systems, but to our internal people, to the public, using the NASA brand for it. So we decided to go out, focus on safety, and do it through operational scenarios primarily. By going into operational scenarios, you clearly need to go through some of the early vehicle certification, airworthiness type things to ensure that what you're going to be doing in an operational context is safe, but it really brings the full big picture together, integration with FAA and such. And you saw some of the early stuff like UTM's national campaigns that kind of pioneered this ground. What we talk about in a lot of ways for national campaign is building a proving ground. So we have a mobile setup that we're able to take out anywhere that industry wants to operate. Could be at our ranges, could be at their ranges, could be in real urban environments as we progress through things. But we build this proving ground to test, collect data that's common across the entire industry, and build out these operational scenarios in a manner that is consistent across the industry, so that we can build requirements that are reflective of the entire industry and consistent across that industry. We have these 5 objectives over here. Really, they're representative, I think, in many ways of a broad set of pillars, barriers, things that the industry needs to do. Some specific things that we're going to focus on with our national campaign and flight opportunities that we don't think can entirely be done in simulation and other strategic means that we have of getting to requirements, specifically the community concerns piece. This is our outward-facing activity where we think we can actually engage the public. We can, leverage our strategies to do real-time surveys, to show the public how it's safe, to show, really show what the noise profile looks like and how people react to it. Get opinions, show the automation in work, things like that. Next slide, please. This is our progression through national campaign. So many of you are familiar with what we did in UTM, and similarly, they had their technical capability levels that went through 1 through 4. We built out a similar progression here. What we've done a little bit differently this time, though, is we've built out a mission worth of projects, if you will. So where UTM was very focused on the airspace piece, and a lot of the vehicle automation technologies were worked in our UAS and the NAS project, focused on a different vehicle size, weight, larger UASs and such. We've really integrated everything into this national campaign concept. So we have all those pillars that I showed you in the previous slide working together and coming together as necessary through this national campaign progression to integrate and really build this whole ecosystem out. We've got a really exciting story going right now. That first yellow X-series simulation that you see out there is something that's ongoing now, getting pretty close to complete, where we've worked with up to 11 airspace partners to go through and look at how they're going to transition their UTM technologies into an urban air mobility environment. A lot of good successes there. Currently, right now, that green bar, we have a dry run test going on where we're working with a helicopter to demonstrate a lot of our first 3 national campaign scenarios. That second green bar, we're going to go out with our primary developmental testing for national campaign partner and fly a subset of those scenarios with Joby on an actual eVTOL vehicle. And then as we get out through NC1, we'll kind of repeat that simulation and flight pattern. Our NC1 partnership pool is fairly large now. We've got up to 4 or 5 different companies that can potentially be flying in that, and we expect to be flying in that. Companies like Alakai, Whisk, Joby, Elroy Air. I hope I'm not missing one here right now. I hate to do that real time, but really powerful set of companies that we think can be flying. And in partnership with Agility Prime, we may bring in other partners like Beta Technologies and others where there's not as much stuff cemented. As we move out to NC2 and beyond, you really start to see sorry, my computer just went to sleep. That's not supposed to do that. Hopefully you can still see me and hear me. Can I get a quick check on that, actually? Back? Okay.
Yeah, we hear you fine, Davis.
Great. It's back up too, so I'll make sure to move my mouse occasionally here. As we move out to NC2 and beyond, complex operations is our first real national campaign that's focused on automation. So we right now have, at the beginning of this fiscal year, have multiple other projects and efforts that stood up focusing on building out automation systems for vehicle and for the airspace side. So this NC2 is going to be very similar to NC1, but it's going to have a lot more NASA research and oomph behind it, partnered with these industry companies to go perform these activities. We have a solicitation for NC1 that's coming out right now. We have most of our partnership base solidified, but this NC2 solicitation comes out in just a few weeks as well, where we'll solidify the rest of our automation partners. We've done pretty good outreach campaign with at least several of the companies that I see on this meeting right now to solicit you, work with you as part of this early automation partnership strategy with a goal of this national campaign too in the near term. And then we realize as we move out towards NC3 and NC4, this industry timeline has some unknowns with it. We don't know how fast industry is going to build this automation out. We don't know what the environment's going to be like. So we have some agility built in, but we do expect to keep to this, at least I expect to keep to this progression and move through even more complex automation scenarios, hopefully in a manner that we operationalize with industry and they're directly following our national campaigns with certification, amendments to their type certifications, and then actually flying operations with automation that resembles what we had in our national campaign. If we can stick to that, we'll have our national campaign progression stay on that same timeline, as well as these unlocks up at the top, where industry takes our lessons from national campaigns and uses them to commercialize. One thing I didn't say is if all this happens, I like to think about this in terms of scalability, being a government agency, and ensuring we get to that UML4 is so important, because when you get to this scalability, you have this automation, all the market studies that we've done and that we see out there, and I think everybody pretty much agrees that automation is going to be necessary to actually get this system to scale and to bring the price points down to a point where a humble government civil servant can actually afford to maybe do something like fly to work, which is a catchphrase I like to say. I live in DC area, about 11 miles outside of the city. If I go to work at the wrong time, it takes me an hour and a half. I might be willing to pay 35 or 40 bucks to get to work on time, or to fly from Dulles Airport after a red eye to get to DC. Could be affordable. And I truly do believe that in that 2030 timeframe, that it is realistic that we get to that point. So, I put in all my energy every day to be a part of that and to make that happen. Next and last slide, I believe, please. And this should leave some time for Q&A. Kind of a call to arms. Everybody, we'd love to see all of you at our AAM Ecosystem Working Group meetings today. PK hosted a supply chain meeting. Next Tuesday, there's a public acceptance meeting hosted by Nancy Mendonca, talking, focused in our community working group. We had a meeting back on November 17th that you can go back and watch and listen to, that documented our full national campaign and AAM research partnership strategy, where we stand. It gives many of your companies opportunities to partner with us, to solicit. You can reach out to me directly or through NARI, which was referenced earlier by you, Wasim. through NARI to get to us and have us explain to you what this partnership strategy is, tell you directly how we think you're fit in. We've done it in a very open manner. Many times there's blackouts and such. We've found ways to do this efficiently, bring in a broad group of people where we can get the leaders in this industry working with us to build out these architectures, to leverage NASA's subject matter expertise and our progression to really find out what's real and get to focus partnerships that are going to help enable this. And this AAWG is founded around that. Founded around teaching NASA what, in forums like this, like what we need to do better and socialize our research, but also just bring the community together. We don't intend this to take away from standards bodies, organizations like AUVSI. We think we can do this all in harmony. I think we've shown we built a pretty good rapport with being able to have a working group set like this, but really not encroach on other people's turf. So with that, I'm happy to be here again, and I'd love to answer a few of your questions if we have a little extra time. But thank you otherwise.
Thank you, David. So that was fantastic. While I pull up the questions, I've got one. So on that previous slide you just showed, you talked about UML4, right? So Amy, I wonder if you can put that back up, that UML4 slide. I suppose my big question is, you've got a 20. I've got to see the date again. I think it was a 2029 date.
2030 would be our UML4.
So the big question is, that's interesting. How does that relate to the FAA, and how do we move that capability? If you go back one slide, Amy, there. So that 2030 unlock, which is fantastic. How does that map back into what the FAA is doing? And have they put that into their plans? I'm trying to work out how do we get there from here, as it were.
Yeah, so we work very closely with the FAA. Many of you probably know a little bit about how we do it. We have research transition teams. We built a little bit of a unique structure with the FAA for AAM. We built out an executive board structure, a little bit separate from the RTTs we traditionally do, but they're the same, more or less. And we coordinate this stuff with them. I would say we're on the same page. This is listed as an industry proposed timeline, so I think we're admitting that it's aggressive, but like I said, I believe in it. I think, if you catch the FAA right and you ask them the question right, you might hear from them more of a 2032 or 2035 type of date for this. And when we do polls, we use our AAWG to survey people. I imagine if we did a survey of 62 people on this call, and kind of showed the bell curve, 2032 or 2035 would be what most of you say for this UML4 as well. We have a lot of data on it now. That's what most people say. But that said, the industry is building and designing in almost all cases towards 2030 scalability. And everybody asks me the question, and I continually watch it. I see no signs of not being able to get there right now, other than history, right? So that's the catch-all. We've all seen what's happened in UAS separation standards and detect and avoid in C2, and we all know the challenges. So maybe common sense says 2030 is challenging. I think the FAA would say that. But again, if the industry keeps building to this pace, if they build the automation capabilities out appropriately, if we can get to the standards on the right timelines, I think we can get there and get to that point. It's more challenging in some use cases than in others. It doesn't include things like M2N necessarily, but we know some of the companies out there want to work on. So I don't know if I'm dodging your question enough or answering it direct enough, but I think the FAA knows what we're saying. I think they haven't said you got to change that, this is impossible, but I think there's a reality that industry needs to move fast, and we need to be doing tests on these automation systems in 2024 that really represent the entirety of what we're defining as complex operations and such. If we're not doing that stuff in 2023, 2024, that's where I said that agility for us needs to come in, right? We need to be able to replan, baseline where we are, change that timeline a little bit, but still keep it reasonable so that the venture capital, the money keeps flowing in and everybody understands that, there's something that's achievable by this date. And so we're going to keep close tabs on that and work to it. And yeah.
Fantastic, Dave. So here, I've got a number of questions, but I'm going to pick on one that is pretty provocative, right? So what do you see? What are you excited to see coming out of New England, seeing as this is a New England summit?
Yeah, sure. So you guys are leaders. I mean, Massachusetts DOT, for instance, is an example. There's somebody, we have a community agreement coming out, for instance, as part of that partnership strategy that we talked about November 17th. I think all similar to IPP, how it went. I think your area up there has a strong opportunity to be a leader in this field, to work with us, kind of help us on things like public acceptance, infrastructure, all that stuff that we're going to need to build this out and understand how it's going to scale across the U.S. I see that as one. Your automation expertise up there in the New England area, you have a bunch of companies that could be working with us in the future. I hope to see that happen. So I look at things like that. I'm probably missing a bunch of stuff, but those are two things that I know excite me, two opportunities that are out there that I'd like to see become a reality over the next less than a year, really.
Fantastic. Great. Thank you, Davis. I'm going to try and cull this one down to make it a little bit easier. So the question here is going to be related around UTM and AIM relationship, the relationship between the two areas. And the question says, the movement of goods has been a focus in Massachusetts, and we can see that evolving faster than passenger transportation. Right? So given that's the required, we're looking at, I'll just make it easier. So with that said, AAM and UTM, how do you see the smaller UAS type package delivery as part of AAM? Is that related, or is that a separate thing, or is it, are they two different, I'll use your word, pipe, or what did you call it? Not stovepipes, but pillars.
Use cases or verticals, or
yeah.
So when we define AAM, in other contexts, I have a full slide on it. Definitely includes small UAS and urban air mobility. We have to, first of all, UTM, we need to get it to the point where it's accepted and used and part of a safety case, right? So I think that's going to happen. I wish it would have been part of remote ID. Sorry to the FAA friends. I think it will be part of BVLOS rules that come out in the future, where UTM will be a mandated part. That's going to make a big jump in this industry. I think it's going to make a huge lead to immediate leaps in how we integrate with airspace, right? It needs to become a real reality first. But then as that happens, and as I agree with you, just the other day, today, I was going through something from Levitate Capital that kind of talked about business cases, market elements for the small UAS, and identified, how cargo and goods would probably come online. I forget the year they said, so I might get a little bit off, 2023, 2024 at more scale. I think Amazon's, Google's and stuff are investing appropriately to make that happen. So the scale, I would expect the scale of the small UAS to be larger before eVTOL scale gets larger, right? And if those technologies are integrated, clearly interoperability kind of becomes a question you have to start answering, right? And leveraging those UTM technologies is going to be extremely important. We know now, our research is, we use a UTM-inspired terminology. The FAA has adopted PSUs, providers of services for UAM. If you look at the architectures, it's just adding UAM onto the below 400 feet UTM architecture, more or less. There's subtleties and differences that I don't want to downplay with respect to, scheduling, trajectories, all that other stuff, hazards in the airspace, weather, things like that. But still, like, you can take those technologies and almost directly translate them to this industry. And as that starts to grow, I mean, I think that's when the autonomy, my personal opinion is that's when the autonomy starts to take off, is when UTM and the scalability starts to take off, is when UTM's implemented, the SUAS are using it, even if it's below 400 feet, I think that's plenty. They're using it in the same types of areas and environments that UAM and advanced air mobility needs to progress. We have research going on, specifically our ATMX project and our system-wide safety projects that are focused on both the small UAS and the UAM use cases. And, so we're seeing all these synergies and we're building them out, expecting both of them to be one, even though we do have a little bit more priority now on urban air mobility because of the economic impact that we expect. But I think that covers what you asked, maybe.
No, that was good. That was good. Yeah. Well, thank you, David. So I think we're actually out of time. There are a couple of other nice questions that I'd like to get to, but yeah, you know what? I'll ask one. I know we're out of time, but very quick one though. So some of the infrastructural components, I mean, how is NASA thinking about that in terms of weather, right? That's, you know, in sensors, surveillance, communications, you know, for the UAS in the NAS program, they had, you know, control non-payload links. Mm-hmm. How is that being used in the AAM environment? There's lots of infrastructural pieces that, you know, is NASA thinking about?
Yeah, absolutely. So ecosystem-wide approach when you think about us. So I'm gonna, in general, if I had a lot of time, I think I'd have a good answer to every one of those things. We have a specific effort that looks a lot like our CNPC efforts previously. They're titled CNSI now. You can see it in that priorities chart, where we're going to be looking to build the CNSI architectures of the future. The upcoming solicitation we have out is going to be asking for CNSI providers to work with us to help us design that architecture, get flight test data, things like that. That expands to a lot of different sensors. Some of the automation research requires sensors that, you know, let you see your operational environment, right, without needing the Mark I eyeball. Weather is a big part of our supplemental data services stuff over on the airspace side. And then we also have a pretty robust set of working group stuff going on weather. We saw an opportunity to lead a little bit there. And then don't forget about actual vertiports. We stood up an activity led by Marcus Johnson, high density vertiplex, that's really looking at what's the automation architecture look like for vertiports in the future. And we're looking for partners across our national campaign for all of this stuff. So, you know, in as simple terms as I can say it, bring it all to national campaign, right? And we want to work together to build out those architectures there and test them and get to those optimal requirements for a scalable UAM, AAM system.
Thank you, David. We are out of time. I'll ask one final question because Mark has asked, what contact information should we use for Davis, right? So, yeah.
Davis.l.hackenberg@nasa.gov, or you can reach out to Nari through our AAWG stuff and get to me. Go to Wasim, he has my email address. Don't be shy.
Fantastic. Hey, Davis, let me say thank you. Thank you again for supporting New England, and I love you saying that New England has a demand signal that you think we can leverage, which is fantastic. Great to know what's happening with the Advanced Air Mobility campaign, and it's great to see. I love the linkage back to the FAA. I suppose from an industry perspective, we're waiting for some of the jewels of this research to become requirements from the FAA and the equivalents around the world, right, in the ANSPs. Mm-hmm. So we'd like to see some of that from an industry perspective. So thank you, Davis. I hope you have time to enjoy the rest of our conference here. And I don't know if you managed to make it yesterday, but we are planning to record and share some of this. So if you're interested, you can see yesterday's dad joke in the recording, right?
Thank you again for inviting me and the Q&A interchange. I appreciate it.
Fantastic.